All right, so before break, we were working on solving quadratics by factoring. And I just kind of want to remind ourselves what that looks like and what the steps are. So we said the first step is to write the equation in standard form, which means that one side must be equal to 0. This is very, very important. Okay. Then we're going to use the x method to factor the equation. I realize there's a lot of steps involved in the x method, but we've already been over that, so I didn't rewrite the steps out here. And then we're going to use the zero product property to solve. This means to set each factor equal to 0 and solve. So you can see we did some examples here where we did just that. These first couple were already equal to 0, so we didn't have to worry about that. We went in, there was no GCF, so we identified A, B, and C. We set up our X, found our factors. Then we wrote those factors here in parentheses equal to 0. And then we used that zero product property where we took each factor individually, set it equal to 0 to find out what the responses would be. And then on problem number 7 here, we had a number on the right hand side of the equation that we had to move over and then do all those steps. It's that type of problem that I was getting the most questions on. So that's the problems we're going to focus on over here on page 31. The directions are going to be to solve each equation by factoring. And the first problem we're going to look at here is x squared minus 12x equals negative 35. All right, so this problem is not in standard form with one side equal to 0, so that has to be our first step. We have to take care of that. So we're going to add 35 to both sides to move that over. So we have x squared minus 12x plus 35 equals 0. Now that we have standard form on the left and equal to 0 on the right, now we can work on the solving by factoring, which starts with our x method, which starts with GCF. In this case, there is no greatest common factor because A is only equal to 1, so we do not have a GCF. A equals 1, B equals negative 12, and C equals 35. Once we've identified A, B, and C, then we can set up our X. 1 times 35 is 35, B is negative 12. So I need two numbers that multiply together to equal positive 35 and add up to negative 12. The only way I can get a positive product and a negative sum is if both factors are negative. So negative 1 times negative 35 is 35. Negative 1 plus negative 35 is negative 36. 2 doesn't go into 35. 3 doesn't go into 35. 4 doesn't go into 35. So negative 5 times negative 7 equals 35. Negative 5 plus negative 7 is negative 12. So there's the combination we are looking for. So one of my factors is negative 5. The other factor is negative 7. The next step we have to remember, even though A is 1, we have to remember we have to come back in and divide by that A value. It does not change my factors here because dividing by 1 does not change. So that means I have parenthesis x minus 5 times parenthesis x minus 7 equals 0. So once I have that factored form, now I'm going to use that zero product property and take each of my factors and set them individually equal to 0. So x minus 5 equals 0. X minus 7 equals 0. I have to solve both of these individually. So add 5 to both sides. X equals 5. And then for the other one, add 7 to both sides. X equals 7. So X is the solution set 5, 7. Problem number 2, b squared plus 12 equals negative 8b. Now again, before I can do anything, I have to have the left side in standard form, the right side equal to 0. So in this case, I'm going to add 8b to both sides. So that I have b squared plus 8b plus 12 equals 0. So again, now my GCF in this case is none because a is equal to 1, so I'm not going to have a greatest common factor. So I have a equals 1, b equals 8, and c equals 12. Set up my x. 1 times 12 is 12, b is 8. So I need two numbers that multiply together to equal 12 and add up to 8. Both my product and my sum are positive, which means both of my factors are positive. So 1 times 12 equals 12. 1 plus 12 is 13. 2 times 6 equals 12. 2 plus 6 equals 8. There's the combination we are looking for. So one of my factors is 2, one of my factors is 6. And then again, I need to make sure I divide by a. And the reason I want you to keep that step in mind, I know it doesn't make a difference here, but I want you to remember that step. So if you are doing one where a is a number other than 1, you remember that step. When we divide by 1, it does not change our factors here. So I have one parenthesis that is b plus 2 times another parenthesis that is b plus 6, and they equal 0. Once I have them factored, then I need to make sure that I take each factor and set it equal to 0 to solve. So b plus 2 equals 0. B plus 6 equals 0. Subtract 2 from both sides here, and I get b equals negative 2. The next one, subtract 6 from both sides, and get b equals negative 6. So B equals my solution set of -2, comma, -6. Okay, number 3. N squared equals 28 plus 3n. Again, I have to make sure that I am moving everything to the left so that it's in standard form and the right side is equal to 0. So the first thing, I'm going to subtract 3n from both sides. So I have n squared minus 3n equals 28. Then I need to subtract 28 from both sides to get n squared minus 3n minus 28 equals 0. And again, now that I have one side in standard form, the other side equal to 0, I look to see if there's a greatest common factor, which there is not going to be. So A equals 1, B equals -3, C equals -28. Set up my x. 1 times -28 is -28. B is -3. So I need two numbers that multiply together to make -28 and add up to -3, which means my larger factor has to be my negative. So 1 times -28 is -28. 1 plus -28 is -27. 2 times -14 is -28. 2 plus -14 is -12. 3 does not go into 28. 4 times -7 is -28. 4 plus -7 is -3. There's the combination we are looking for. Yes, absolutely, because of the -3, the 7 has to be the negative, because that's the only way I'm going to get a negative sum. So when you're determining positive and negative, you have to look at your sum. If your product is negative and your sum is positive, that means your smaller factor is negative. When your sum is negative, then the larger factor is negative. If your product is positive and your sum is negative, then both factors. But it does matter because you need that -3. If I had had -4 plus 7, that would have given me a +3, and it wouldn't equal that -3. So one factor is +4, one factor is -7. Okay. Again, divide both sides by a, which does not change my factors. So 1 parenthesis is n plus 4. 1 parenthesis is n minus 7 equals 0. And again, the last step then is to take those two factors individually and set them equal to 0 and solve. So n plus 4 equals 0. N minus 7 equals 0. So here I'm going to subtract 4 from both sides and get n equals -4. On the other one, I'm going to add 7 to both sides. Get n equals 7. So n equals the solution set -4, comma 7. So again, here's some extra practice on problems where we have to do some moving around before we can start any of the steps. It has to be, one side has to be in standard form, the other side has to be equal to 0.